The simple explanation is that your bladder is a balloon with nerves. As it fills, the walls stretch, and these stretch receptors send a signal. But this is like saying a computer works by doing math. The truth is far more elegant. The cells in the bladder wall, the detrusor muscle, aren't just passive elastic tissue. They house mechanosensitive ion channels, proteins called piezo-1 and piezo-2. When the cell membrane is physically deformed, even slightly, these channels pop open, allowing ions to flood in. This isn't an on-off switch. It's a high-fidelity conversion of physical force into a graded electrical currency, the first whisper in a long conversation. But the muscle cells are only part of the orchestra. For decades, the innermost lining of the bladder, the urothelium, was dismissed as little more than biological waterproofing. We now know it's a sensory surface, a computational layer. As the urothelial cells are stretched, they don't just endure the pressure, they respond by releasing chemicals. Specifically, they release adenosine triphosphate, or ATP. That's the same molecule your cells use for energy. Here, it's repurposed as a neurotransmitter. The urothelium is actively tasting the stretch and broadcasting the information chemically into the space just beneath it. This chemical broadcast of ATP doesn't travel far. It's meant for a very specific audience. A dense, intricate web of afferent nerve fibers located just under the urothelium. This suburothelial nerve plexus acts like a microphone array, listening for the ATP signal. This creates a two-stage amplification. The physical stretch causes a chemical release, which in turn triggers a much stronger electrical signal in these nerves. These nerves are not all the same. Thin, unmyelinated C fibers transmit the general, background sense of fullness, a dull, low-grade awareness. But as the bladder becomes very full, the faster, myelinated A-delta fibers kick in, carrying the sharp, urgent signals that you can't ignore. These signals, both dull and sharp, race up the spinal cord. But they don't go directly to your conscious mind. Their first major stop is a region in the brainstem called the pontine micturition center, or PMC. Think of the PMC as an unconscious gatekeeper, a master switch. It receives a constant, real-time stream of data about your bladder's volume from the moment the first milliliter arrives after your last void. For most of the day, its job is active suppression. It sends inhibitory signals down the spinal cord to keep your external urethral sphincter tightly closed and ensures the large detrusor muscle of the bladder wall remains relaxed. Your bladder is full, and your brain knows it long before you do. The information is simply being handled by a lower-level manager. So, when do you get the memo? As the signals from the bladder nerves become stronger and more frequent, the PMC reaches a threshold. It decides the information is now relevant to the CEO. The signal is then relayed upwards primarily to a region called the insular cortex, the brain's headquarters for interoception, the sense of your body's internal state. Here, the raw data of nerve firings per second is translated into the subjective, qualitative feeling of fullness. It's no longer just data, it's a sensation. This sensation is then passed to the prefrontal cortex, which integrates it with context. "I feel my bladder is full," the insula reports. "But we are in a meeting," the prefrontal cortex replies. "Initiate suppression sequence." And even this is not the full picture. The nerves aren't just sensing volume, they are sensing wall tension, a concept governed by Laplace's law. This law states that tension is a function of both pressure and radius. This is why a rapidly filling bladder feels fuller at a lower volume. The wall is stretched taut, creating higher tension. And finally, within the bladder wall itself, there exists a network of cells that are not nerves and not muscle, but something in between. Interstitial cells of Cajal-like cells. These cells act as local pacemakers and signal integrators, forming a kind of peripheral brain. They can modulate the muscle contractions and sensory signals before they ever even begin their journey to the spinal cord. The awareness that eventually percolates into your consciousness is not a simple alarm. It's the final, edited report from a deeply intelligent, self-regulating system that has been managing the situation autonomously all along.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.